Let's get started. Let's understand now. SQL Server can be implemented in on-premises, right? Your company's data center. So assume this is your company's data center, your on-premises environment, and this is your SQL Server. I'll paint it green, and we can implement within your company's data center. There is one option, and if it is on-premise environment, I'll paint database as light color, okay, like this. If it is on-premise data center, we can have multiple instances. Of course, in production, we have only one instance usually, but if required, we can have multiple instances, right? Okay, in this way. Next. This is on-premises, okay? This is one style to implement SQL Server. So option 1, I'll write like this. Option 1, on-premises SQL Server. Okay, next. And there are few features that we are going to get them listed now today in next few minutes. Okay, we are going to have certain features that we are going to list them today. Okay, next, let's continue. Other one. This is one option that we're going to learn with all the features. Option 2, we have option 2, Azure PaaS, okay, Azure Platform as a Service. Azure PaaS environment, platform as a service, meaning majority operations cloud will take care. Here in PaaS, again, in a single PaaS environment, we can have multiple servers, but we don't call them instances. In on-premises, each item or each server is called an instance. In Azure, each server is independent. There are platform independent environments. In PaaS, we can buy a group of databases. So we can pay per database separately, or we can pay per group of databases separately. We call it as elastic pools. Okay, here it is. This is elastic pool. Like this. I'll just put this one. Okay, this is elastic pool, something like this. Next. Okay, in this way. This is an elastic pool. And in this elastic pool, I'll just make sure things are easier. Okay, like this. Next. Then we have other one, Azure EAS, Infrastructure as a Service. EAS, Infrastructure as a Service. In Azure ES, we have again the concept of instances. So PaaS is something different, wherein each server is independent. Each server is independent, whereas ES is similar to on-premises, non-cloud environment, wherein we can install multiple instances. No concept of elastic pools. Let's understand the difference between these three different implementations. I'll just title this entire information as the SQL Server implementations. Practical implementations of SQL Server. We have other things as well, like managed instances and something called as Google Cloud, Amazon, AWS installation, implementation of SQL Server. I'm not touching them. I'm taking the regular, frequently used practical implementations of SQL Server. Okay, let's see. Here we go. In the first option, on premises, let's understand the differences and limitations. Okay, let's see both. First, features on premises. We pay per server. Per server, we call it as CAL, client access license and device access license, etc. Pay per server or instance. Okay, this is the first thing. And other one, I'll just get these items here. Just wait, okay? Just let's make it clear and simple. Yes, so here we go. We pay per instance on my screen. Whereas here we pay per database. We pay per database. Or sometimes we also pay per group of databases called pool, elastic pool. Here we pay per virtual machine. We pay per VM. Inside VM, we can have any number of servers again. Remember, that's the main difference. You observe the difference carefully. Licensing at server level, database level, VM level, virtual machine. Next, can be implemented in any OS. Of course, Windows is recommended, but can be implemented in any OS. Whereas here it is, there is no OS dependency. Hence, we call it as serverless. Okay, remember, this is called serverless. Here, serverless means OS-less, operating system-less. Let me show you practically what it means, just to make it more easier. What is this? We call it as serverless. Okay, remember, means OS-less. What is that? Let me show you. Let me log into portal, my Azure portal. Let's log into Azure portal. It's taking some time here. Let's wait. It's taking a bit longer time. I'll just simply close my other browsers. other browser extensions. Should be almost immediate. Anyway, I'll quickly, I just refreshed it. It's working fine now. I log into my cloud account, my Azure cloud account. There is something called serverless. Okay. In case if we get a question in your interview, what is serverless? Or how do we verify serverless? Or what kind of SQL Server implementation supports serverless? How do we get it? Let's see. In Azure portal, there is one resource category called Azure SQL. This one, Azure SQL. Go to Azure SQL. Okay, next. Once we go to Azure SQL, click on this Azure SQL, create. Let's click on create. There are three options, okay? In Azure SQL, there are three different flavors. One of them is serverless. This one. This is called PaaS, Platform as a Service. We call it a serverless compute. By default, the limit is up to 4 terabytes. Can be extended up to 100 terabytes. Serverless. This is nothing but logical server, we call it. Logical server. Other one is OS dependent VM, virtual machine, EAS, infrastructure as a service. This is serverless, okay? First one. This is the one I'm talking about. Serverless compute. I'll just put this one. So here we go. This is called serverless. And we call this as physical server. This is called logical server. And this is called virtual server. This is a terminology we use. Let me show you this terminology practically in the Azure portal. Click create. The first one, serverless. You click create. It prompts you to create one server. Of course, we are clicking on database. The database requires a server. I click on create new. It will take me to a server. This is called logical server. Or other option. It's asking for server name, location, authentication, and admin name, right? This is called logical server. I'll show it again in a different way. Go home. Click on create resource. SQL server, logical server. This one. So their first option, serverless create, is there, right? It's nothing but logical server only. Click create. This one. Once you click create, click. It will again take you to the same interface. Server name, location, admin name. Okay. So SQL database server is called logical server in PaaS, platform as a service. Other one is virtual machine. So we have something called virtual server here. Next. So these are all the properties we are learning. Now advantages of each. Okay, advantages. Coming to advantages in each of them, let's see. Firstly, the first major advantage of on-premises server. Here in on-premises, we have more control on data and the environment. We can stop and start the service whenever needed. We can back up a database wherever required. We can stop a database whenever required. Full control. But it's not the same case in PaaS. In PaaS, main advantage, automated maintenance and cleanup activities. Unlike on-premises, in PaaS, we have automated history cleanup, automated expired backup cleanup, automated patches, automated security updates, automated maintenance, index management, statistics management, everything automated in PaaS. In IaaS, infrastructure as a service, here also automated maintenance and cleanup, but at the same time we have control on the resources, control on processor, memory and disk. We can define what kind of disk you wanted to, how much memory and processor you wanted to allocate. Whereas here it is serverless, we don't have that control at all. One more advantage of on-premises, it is comparatively cheaper. PaaS, there is an advantage, cheaper than Azure IaaS, infrastructure as a service. This is a bit costly. Comparatively, IaaS is costly. Next, one more advantage. If you go for PaaS or IaaS, here we have easy HADR setup, high availability, disaster recovery setup, and easy security implementation. Main advantage of IaaS, traditional HADR setup like on-premises. Like old replication, log shipping, mirroring, everything possible in IaaS. Just like old replication. So the lift and shift is easier. I'm maintaining the same colors here just to make sure they're identical. The interface is identical between on-premises and IaaS. At the same time, we have flexible security implementation with OS dependency, like Windows authentications are available here. We don't have such OS dependency, Windows authentication in PaaS, not possible. Then we have limitations. Limitations with on-premises. Slow performance or low performance for big data. If you go for Azure PaaS environment, slow performance for very large databases, very big data, very large database. We'll say technically we call it as VLDP, slow performance. Whereas here, ultimate performance, but costly. It's the main limitation. Between PaaS and IaaS, there is a limitation here. No control on service and file system location of your database, like creating multiple log files, data files, file groups, not possible. Whereas IaaS, yes, we can happily control the service. We can happily create new files, data files, log files, etc. We can, but there is a limitation. Manual maintenance and manual monitoring operations like profiler, DTA tool, the database tuning advisor tool, they're all manually to be implemented here. Next, real-time use. When to use what in real world? Let's see. Okay, I'll just include it here in this way. Real-time use. On-premises environment, because it is cheaper, we can use it in development and test environments. And we can use it in small scale enterprises, small scale projects based on their revenue. Same way. I'll just add one more entry here, okay, just to make it clear. Yes. If we go for this second one, Azure PaaS environment. If it is Azure PaaS environment, then where it can be used? Here, it very important. Azure PaaS environment has certain limitations. So accordingly, we need to limit its usage based on the size of data. It will be used in dev and production environment, but small scale projects up to 100 terabyte. By default, 4 terabyte size. By default, let me show you. During creation of database in PaaS environment, platform as a service, by default, you see up to 4 terabyte. Let me scale up and show you here. I have one practice database for our training classes. I'll scale up the database. Default minimum it is 2 GB plan. Go to premium and max limit is 4 terabyte, 4096 GB. Premium plan. And there is something called hyperscale. This one, hyperscale, we need to decide to set hyperscale during database creation itself. There we have unlimited capacity, theoretically, practically up to 100 terabytes. Bit costly. Whereas here, simply say small scale project and up to 100 terabyte. But what if you would like to store petabytes of data, unlimited amount of data? We don't know the size of data, like social media or any kind of healthcare, banking, or infrastructure or e-commerce kind of scalable projects where data may grow exponentially overnight. We don't know. So if you want such database system capable enough to welcome any volume of data, virtual machines is the best option. Here it is. Supports VLDB, very large databases. Okay, next. I'll just format the entire notes to make it easier. Once again, I'm not listing all options. I'm listing only the main options here for our quick and simple reference. So these are all the properties that we are learning. The first items are about the properties. From properties, we learned the advantages. And here, if you compare advantages, the main advantages here, we see virtual machines always win the match. And next, limitations. Coming to the limitations, as slow performance in case of on-premises. Why? Because of network involvement. Remember, cloud infrastructure involvement is always faster because they have their own satellite networks, virtual fiber optic channels, which are far faster than a regular enterprise environment. So performance-wise, cloud always wins compared to regular localized environment. We think usually, okay, local environment is faster, but not really all the time. For example, assume your company's data center is in Redmond. Assume US Redmond city. You try to access the data from India. In olden days, it used to have a lot of traffic. So we used to maintain something called empty servers, middle tier servers in between. Empty servers we used to call it. I was talking about my first initial job days, 2005, 2006 at that time. When I was working for Microsoft, we used to have one project called BGIT project. I used to work for this project, BGIT, Business Group IT. Later, they modified it as Business Group Center of Excellence. BG is still there, still internal project in Microsoft. It will be an evergreen project because we have those items for source depot and window bugs, OS, office bugs, etc. Later, I was into Merrill Lynch project, and the Merrill Lynch bank got bankrupted during 2008 recession. Other things, that's okay. But my initial job at Microsoft, we used to have BGIT, and there we used to have three different environments, three different data centers. One in Redmond, western side, one in Dublin, Europe, and one in Singapore, Far East. So three different strategic locations to cover 24/7 availability of data. Redmond, Dublin, Ireland, Europe, and then Singapore, Far East, APAC region, Asia Pacific region. So we used to have three different physical data centers, and it was very costly for Microsoft. And I still remember in 2009, I think, some pirates, they cut these C cables, underlying C cables in few areas, and we faced the outage. It's not the case now, right? We are lucky enough, we have cloud everywhere, and it's all through satellite and fiber optic network. We are able to get the content faster, easier, big data. So, yes, it's all about cloud we are learning. And the project revenue will decide whether to go for PaaS or IaaS. But it's highly recommended to have both in your project environment and do live replication. You host few databases in PaaS and replicate them to EAS or vice versa, so that even if something goes bad in one region, though it is cloud, one region, assume there is some outage, still we can recover the data back and ensure 24/7 availability of data from the other server. I mean to say, remember, whatever data we have in on-premises can be replicated live to Azure. Whatever data you have in Azure PaaS can be replicated live to EAS also. But this has more scope compared to on-premises. So this is a complete comparison chart to get some idea about the implementations of Microsoft SQL Server, cloud versus non-cloud. Any questions, clarifications? I'm always available. Do reach me for further information or questions if any.